Hi, today I'm going to teach you exponents. Again, there'll be many parts to this lesson. In the first part, I am going to explain to you the laws of exponents for integral powers. What are these words? We never use English to understand them. That's why things become even more complicated. Let me first talk about what an exponent is. An exponent is also called an index, and the plural of index is indices. These are also known as powers, right? So exponents or indices or powers is what I am talking about. And you know that I think roughly you would be knowing what I'm talking about. I am talking about the form where you have integers, and integers are the power or exponent. So these will be integers that I'm talking about, but they can be fractions also. But when I talk about exponents, I am talking about this. A into A into A into A is equal to A raised to the power of n. This means A raised to the power of 1, A raised to the power of 1, A raised to the power of 1 and 1. And this 1 plus 1 plus 1 plus 1 will be equal to 4. Right? So, I can say, I don't know how many of these are there, but if I have many of them, I can write this with a dash, dash, dash over here. Let's see how. Is equal to A raised to the power of n, right? So when I talk about this, I can say that I have A multiplied to A n number of times. So this is known as my exponential expression because I'm writing it in the form of an exponent along with this number. What is this number known as? This number is known as the base, and this number is known as the exponent or the power or the index. Is that much clear? Now when I'm talking about this, I can say A raised to the A raised to the power n. Right? Now, there are 3 laws that I want you to remember, and this is what I'm going to do in this particular class. And that is the laws of exponents. And laws of exponents is not the only thing I'm saying here, because I'm keeping it simple right now. So I'm writing for integral powers. What is integral powers? Integers. Could be plus, could be minus, could be 0 also, because integers are negative numbers also, negative whole numbers, positive whole numbers, and 0 also. Before I start with the laws, I want you to remember that anything raised to the power of 0 will be 1. So 8 raised to the power of 0 is equal to 1. 2 raised to the power of 0 is equal to 1, and so on. So when I have this and I remember this, there are things which become easier during my calculations. So coming to the laws of exponents, the first one is product law. The second one is quotient law. Product law, quotient law, and power law. Power means exponents, right? Now let's see what product law is. It's very simple to understand. If I write 2 raised to the power of 3 into 2 raised to the power of 4, what will it be? If I have to write the exponential expression only, I'm not calculating, I just want to write the exponential expression, which is the base and the power. So this can be written as 2 into 2 into 2, right? And then I write into, and then 2 into 2 into 2 into 2. So this becomes 2 raised to the power of 1, 2, 3, 4, 5, 6, 7. Right? So is there any other way that I could have done it? Of course. I could have simply written 2 raised to the power of 3 plus 4. I could have added the powers. So this is my product law. What is my product law? I can write it in this particular manner. A raised to the power of m into a raised to the power of n will be equal to a raised to the power of m plus n. I hope this is clear. Otherwise you can rewind it and keep checking. Quotient law, beta. Now what is quotient law? Quotient means divide. This much all of us know. So if I have, let's say, 2 raised to the power of 7 divided by 2 raised to the power of 5, it will be 2 raised to the power of 7 minus 5, right? And this will be equal to 2 raised to the power of 2. You didn't understand this, is it? Koi baat nahi. Let us see what I'm saying. I can write it in this manner. What was the answer? 2 raised to the power of 2. I can write 2 into 2 into 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6, 7. So that's 7 upon 2 into 2 into 2 into 2 into 2. 5 times. Then 2 ones are 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 2 ones are. What is left, beta? 2 raised to the power of 2. Is that right? So I could easily write this in a much more simpler manner, and that would have been what? Simply written it as 2 raised to the power of 7 minus 5 equal to 2 raised to the power of 2. Is that clear to everybody? Here there is a slight catch. Let me explain what that is. Supposing this was 5 and this was 7. Then what would happen? Then I would write 5 minus 7, and then it would be 2 raised to the power of minus 2. Yes, the larger digit is 7 and the other digit is 5, the smaller one. When one is plus and the other is minus, we subtract. And this becomes 2 raised to the power of minus 2. And this is written as 1 upon 2 raised to the power of 2. The reciprocal. Anyhow, if you've understood this, let me explain this. This part. 2 raised to the power of minus 2 means it is 1 upon 2 squared. So, I can say that there are 2 parts to this quotient law which we must understand clearly. The first part is that if I have a raised to the power of m upon a raised to the power of n, the answer will simply be a raised to the power of m minus n if m is greater than n beta. Okay? And the second part is if it is still a by a raised to the power of m upon a raised to the power of n, and n is greater than m. So I write n is greater than m. Then I will write this as 1 upon what? A raised to the power of n minus m. Right? Now let's go to the third one. The third one is the power law. Very simple. If I have a, for example, 2 raised to the power of 3 raised to the power of 2. How will I write it? I will write this as 2 raised to the power of 3 into 2 raised to the power of 3. Isn't that what I will do? Because the square of this, right? And then it can be written as 2 raised to the power of 3 plus 3 is equal to 2 raised to the power of 6. So it is 6. Do you think I could have also done this? The answer is this. But do you think I could have written this simply as 2 raised to the power of 3 into 2? It would have still been 2 raised to the power of 6. So the power law is quite simply a raised to the power of m whole n is equal to a m into n, can be written as a m n. Is that much clear? So I'll go to the next little thing which I need you to remember so that you don't make any mistakes here. What is that other thing? Well, if I have a negative number, supposing it is minus 2 and it is raised to the power of 2. So what will happen? It will become minus 2 into minus 2 will be 4, of course, and minus into minus will be plus. If it is minus 2 raised to the power of 3, it will be minus 2 into minus 2 into minus 2 is equal to minus into minus is plus, plus into minus is minus. So 2 2s are 4, 4 2s are 8, but minus. That is not the purpose. I am not talking about what is happening to 8. I want you to look at this. If it is 4, minus 2 into minus 2 into minus 2 into minus 2 will be equal to minus into minus is plus, plus into minus is minus, minus into minus is plus again. 2 2s are 4, 4 2s are 8, 8 2s are 16. I can also write this. If it is minus 2 raised to the power of an even number, look at this, even number, then in that case I can simply write this as equal to 2 raised to the power of 4, right? And I don't need to write this minus minus again. And here also I can simply write 2 raised to the power of 2. So this basically means that if the power n, if n is positive, then what happens? Even if this number is negative, I can simply say that this whole number will become positive. I can write it as this in both these cases. If it is negative, if it was 5 also, it would be negative. So, supposing, let me give you this example of 5 also. Is equal to minus 2 into minus 2 into minus 2 into minus 2 into minus 2. Minus into minus is plus. Plus into minus is minus, minus into minus is plus, plus into minus is minus. So this means that when the number is negative, if I have is odd, if my n is odd, this can be written as 2 raised to the power of 5. I can write minus 2 raised to the power of 5, and this will become minus 2 raised to the power of 3, meaning whatever answer I get, this can even be here. I can also write this as minus and 2 cube. I can write this as minus 2 raised to the power of 5. I don't need to go that far ahead. I can simply say that when I have a number like this, this will become a minus number if n is, if not n, I've written n. If n is even, the number will become positive, and here if n is odd, it will become negative. Alright? Is that clear? So, if this is clear, I can quite easily say that you will be able to do most of the first exercise, which is basically very simple things over here. So I would suggest that you try out the exercises given in your book and use this. There are other things which I'll tell you in my next chapter.